Welcome to AP Physics Made Easy. In this episode, we're going to look at kinematics equations. So these are the kinematics equations that we'll be working with a lot during the AP Physics year. They're super useful. I like to say they're the main tool in your toolkit, right? They're the ones you're going to reach for the most when you're trying to solve a problem. And here's why. They let you solve for things that we tend to measure a lot. And I'm talking about things like the displacement of an object in meters, its velocity in meters per second, its acceleration in meters per second squared, how long it's been traveling or accelerating in terms of seconds. But one thing you have to keep in mind with these kinematic equations is this. They only work if the acceleration does not change. So you need to be mindful of that, and we'll talk about that as we go through the year, but I just want to get that out there right now. Let's start with the first of them. Velocity average is equal to delta x over t. Please listen to what I'm going to say because this is so important. This is the one equation that you have to use if the object is not accelerating, and you cannot use it if the object is accelerating. Let me say that again. This equation, V average, cannot be used if the object is accelerating because it only works if the average velocity stays constant, which means it's not accelerating. Now, that will happen a lot in AP Physics, especially when we're dealing with ballistic problems, which we'll look at in our next video, but just please keep in mind, don't try to use this for motion that is accelerating. Now, let's just break this down a little bit. We've talked about this in previous videos, but the symbol delta, which is here, this little triangle, it always means the final value minus the initial value. Whatever the variable that comes after it, if there's a delta in front of it, it means the final minus the initial. I want to point out something here that I find a little bit frustrating. You will use this equation a lot on the AP test, and yet it's not on the AP equation sheet. And that brings me to another thing. Please don't rely too much on the AP equation sheet. You're a smart person. You don't need the equation sheet. So we've already looked at this equation in a previous episode, but I'd just like to talk about it right now. So the definition of acceleration is the change in an object's velocity over the amount of time it took to implement that change. This does get used a lot. Now here's the thing about the kinematics equations. It's knowing which one to use when is what the real trick is. Not really remembering them, but it's knowing which one to use. Here is a trick I've emphasized with my students for decades. Are you ready? It is this. You want to choose it based on what you don't know or don't care about. So when I look at this equation here, I notice that there's nothing about where the object is. I don't know about displacement. They didn't tell me in the problem what the value of x was or where it was. They didn't ask about it. If that's the case, if I don't know or care about displacement, this is your go-to equation. So let's look at an example. I have a car initially traveling at 5 meters per second. It accelerates at 2 meters per second squared for 6 seconds. What's the car's final velocity? There was nothing in this about where the car is or how far it displaced. So this is the tool in my toolkit that I'm going to reach for. And then I'm going to say, final minus initial is what delta means. I substitute in, and I get my value. Let's talk about this. On the day of your AP test, time is your enemy. I'd like you to get a 5 on this test. And to get a 5 on this test, you've got to be efficient with your time. You can't spend your precious time looking around the equation sheet for which one you're supposed to use. Students who do this don't do well on the test. It's one of the reasons people do poorly on the test is because they tell themselves, well, they're going to give me this equation sheet. Trust me, you need to memorize every equation on the AP equation sheet. You can do it. You've got the time. Put the time in now, and you'll be grateful when you get to that test. Now, let's just look at this. I teach my students to think about acceleration this way. What is the definition of acceleration? Well, it's how much you change your velocity divided by how much time. It's going to be measured in meters per second per second. This is a great way to remember it. Look at how they put it on the AP physics sheet. Like this. On their equation sheet, it looks like this. Now, mathematically, this is very true. I almost feel like they did it to say, like, hey, look, we didn't really want to give you this equation, but if we're going to rearrange it in a way that makes it as confusing as possible. Maybe that's what they did, maybe not, but I kind of feel that way. Now, let's unpack this a little bit because I know some of you are going to want to use this equation sheet. And, it's not wrong, but I just recommend you don't. So let's just look at it. First of all, they put this x here and here to say, well, we're talking about in the x direction as opposed to the y direction. I don't know why they didn't put it here, but they did. All right. The other thing is they use the symbol like a lot of teachers do, like maybe yours does. They put a little 0 here. We read it as naught. So we say this is v naught. And that just means at time 0. So this would be your initial value, and this would be your final value. I'm not a fan of it. I'm going to teach it the way I think is easiest to memorize it. So If you follow along with me, I think you'll have a better chance of doing well on the test. But if you're going to use the AP equation sheet, it's on you. All right, let's keep going here. All right. In many cases, you're asked to solve problems that involve gravitational acceleration. And they don't say, and by the way, it's accelerating. So if an object is falling, it is on you to understand that it is going to accelerate in the downward direction, and that A, acceleration, would be therefore substituted with the variable g for gravitational acceleration. So this is one of the unspoken assumptions on the test, and you really need to be cognizant of it starting now, okay? So these kinematic equations, apart from that first one, always involve acceleration, and in many, many, many cases, that acceleration is in the downward direction because of gravity, so you need to substitute it with g. Now, a lot of times you're not going to solve it mathematically. You're going to write expressions. We'll talk about that in a future video. But if you do have to substitute in, you're going to use -10 here. All right, so here's our equation. This is what you're going to substitute it with. So we're just saying we're going to use g instead of a in most cases. I suggest you use 10 instead of -10. And the thing is, it's better to write it as g than to just substitute directly in with 10. And the reason is we want this to be true in other places, on the moon, on a different planet. So when we write expressions, we're going to use g rather than substituting it for the number 10. Okay, let's just say I'm given a problem where they don't tell me how long the object's been traveling, and they don't ask me how long the object's been traveling. In that case, this is my go-to kinematics equation. It's the one that doesn't involve time. I take the final velocity squared and set it equal to the initial velocity squared plus 2 times the acceleration times the displacement of the object. Let's look at an example of a problem with this. So I have a ball that's launched upwards at 30 meters per second in the upwards direction, and I'm asked to find out how high is it going to go. That's all I was told. Now, I wasn't asked about time, I wasn't told about time, so I know I have to use this equation. Now, in order to use it, I need to know what the final velocity, initial velocity, acceleration, and I can solve for displacement. So, a couple things here. One is that I have to keep in mind that at the top of a situation like this, at the apex, this object is going to momentarily stop and then change directions. So at its apex, at its highest point, its velocity, its final velocity is 0. So that's an idea to wrap your head around early on in the year, okay? The other one is that even though it wasn't specifically stated, hey, there's gravity, or hey, you're on Earth, you are to assume, unless you're told otherwise, that you are on Earth and that gravity is still operating in the downward direction. So therefore, I would substitute A with -10. And the reason I had to make sure I use that negative in this case is because the object's initial velocity is in the positive direction. So I'm going to put negative here to indicate that the gravity is acting in the opposite direction, and then I solve for it, and I'll get 45 meters of height is how high it would go. This brings us to our last kinematics equation. It's the one to use when all 4 kinematics variables are present and accounted for. So we have displacement, we've got velocity, we've got time, and we've got acceleration. This is a useful equation. I have my students use it in lab when we're doing, say, ballistics problems. However, I've noticed that College Board usually doesn't make you actually calculate with it, but what they do often have you do is in an MCQ, they'll give you a scenario and they'll say, which of the following equations would be the appropriate one to use? And the answer is if all 4 variables are in play, this is the one you have to use. You know, the way you chose the other ones was by what was missing. Well, nothing's missing. Let's look at an example. So let's just say I have a car that's initially traveling in the positive direction, and after 4 seconds it comes to a stop after having traveled 20 meters and slowing down at -5 meters per second squared. And what I want to know is how fast was it initially traveling? Okay, so all I have velocity, I have time, I have displacement, I have acceleration. This is the equation I'm going to have to use. So let's just start substituting in. Now, I've got to be careful with my positive and negatives. If it's traveling to the right, I'm going to call it the positive direction and make it a displacement +20. The time is 4 seconds. I have to put in both places, and in this case, I have to square it. And since it's slowing down as it moves in the positive direction, that makes it a negative acceleration. So I'm going to put a negative here. And then when I solve for it, I'll come up with 45 meters per second was its initial velocity. And again, it's a useful equation, but you usually won't do calculations with it on the AP test, but you do need to have it as one of the kinematics tools you know when to reach for. Here's something about this one, though, that's really important. In most cases that you're going to encounter on the AP test, the object is going to either start from rest or end at rest. So the initial velocity or final velocity is going to be 0. And if I substitute a 0 here, this entire expression turns into this baby right here. And I'm telling people, please listen to what I'm saying now. This right here is the most important equation in AP Physics 1. It is so useful. You will use this one a dozen times, 24 times on the AP test. I promise you. It's so important. I suggest you get it tattooed on your arm. It's that useful. Delta x equals 1/2 AT squared. This equation is your friend. This equation is your ticket to a 5 on the test. You need to learn it. All right. Now let's just look at how they often present questions, say, in an FRQ portion of the test. They like to say, like, oh, you have access to a meter stick and a hand timer and a ball rolling down a ramp, and we want you to find the acceleration. How would you do it? Okay, so being limited to a meter stick and a hand timer, that is really classic AP Physics type of stuff. And that means then that you're going to have to use this equation to solve it. So you're just going to start with this equation here. And you say, look, I can use a meter stick to measure the displacement. I can use my hand timer to find the time. And therefore, I can just solve for the acceleration. So you're just going to tell them, I'm going to start with this equation. I'm going to work to isolate the a, so I'm going to multiply both sides by 2 to clear out the 1/2. Then I'm going to divide both sides by t squared, and that's how I'm going to find it. Boom. As always, thanks for watching. If you like this video, remember, like this video. Consider leaving me a comment. If there's some video you'd like me to make, I'd be happy to do that, or maybe you could just give me some feedback on how to improve. You might want to check the description below to see if there's some links I've included that could help you out. And of course, as always, I would really appreciate it if you would like and subscribe.